Okay, so this is the problem that we're working on right here. And you got the first two steps totally right. Combining the equation to one overall and finding the intermediate, that's entirely correct. But in order to find the rate, we got to do something a little different. So, there we go, it's a little better. The first thing you want to do when you're trying to find the rate is when it's one of these problems where the slow is the second step. All right, so make sure when you're doing this process that the slow is the second step and not the first step. All right, because if it's the first step, you don't have to do any of this. But if it's the second step, that's when you want to do this process. All right, now the first step is you're going to want to write the rate of the second step, the slow step, okay, because that's the rate of the overall equation. So we're going to write rate overall. This is what we learned today. The rate of the overall reaction, right, when they're combined, is the same as the rate of just the slow step. All right, that was kind of like the big concept that Professor White wanted us to get. The rate of the overall equation is the same as the rate of the slow reaction. All right, so if we take that and we write it, we get the rate of the overall reaction is equal to K times the concentration of NO2Cl, come on, pencil, times the concentration of Cl. Right, we know how to do this. We've done it 1,000 times already. All you do is you take the two reactants and you put them in brackets. And then, so this is a little tricky. Actually, I won't get into that now. All we need to know right now is, there we go. To find the rate of the overall reaction, we first take the rate of the slow step. All right, does that make sense? Sorry, I'm being kind of jumbled right now. But that's the first step, all right, is to do this right here. Now, if we look at this, we see that we have an intermediate in the reaction rate, which we can't have. That is not allowed. Remember, I saw you put in the answer that Cl is an intermediate, and that's correct. But the problem is we can't have intermediates in the reaction, all right, because intermediates disappear, basically. We don't really need to know why that is. All we need to know is that this can't be here, this Cl right here. So in order to get it out, we have to trade it in for something else, all right? And the way we do that is we're going to look back at this top equation, the fast one, all right? And all we're going to do is we're going to make the two rates of these two equal each other, all right? So what we're going to do is we're going to write the rate of K1. I'll just call this one right here K1, all right? K1 is this one. The rate of K1 is equal to the rate of K negative 1. All right, I'm just going to call this one right here K negative 1. Rate of K1 is equal to rate of K negative 1. Now we're just going to do the exact same thing we did in the last step. We're just going to plug those rates in. All right, so the rate of K1 is just K times NO2Cl. Right, that makes sense. We know how to do that. And then the rate of K negative 1, which is this half right here, not this one. This is K1. This is K negative 1. Ooh, there we go. The rate of K negative 1 is K NO2 times Cl, right? We know how to do that. We've done it a few times. So that's the next step, is we find the two rates of these and we equal them to each other. All right. Next, we're going to solve for the intermediate. All right, remember, this intermediate is the one we want to get rid of, so we want to make this one be by itself. So in order to do that, we're going to divide both sides by this KNO2 term so we can get just this Cl by itself. So what that's going to look like is K all right, we got this term right here. This is just the same thing. And then we're going to divide it by this term right here so we can get the Cl by itself. On the bottom, we're going to do the KNO2. All right. Okay, and now we have the Cl by itself. Hopefully that makes sense. So all we're doing is we're just trying to get the Cl by itself. All right, so whatever you need to do, it could be dividing something. In fact, that's going to be the case every time, is you're just going to divide something by something to get the intermediate by yourself. Remember, you're just looking for the intermediate so you can sub it out. All right, so now that we have this by itself, all we're going to do is whenever we see this in this first equation, the one we found for the overall, we're going to plug in this, right? Because these are the same thing. So basically, we're going to put in this right here into this CL. All right, so what's that going to look like is we're going to get our rate overall. This is the exact same as the first step we did, right? Finding the rate overall is equal to K times, oh my, come on now, K times NO2CL, right? The exact same as what we have right up here. Oh, wait, I'm sorry, right up here so far, right? Except for this intermediate, we're going to plug in what we just found, all right? So instead of CL like we did up here, we're going to put this, what we just found. All right, so that's going to be, excuse me, KNO2CL over KNO2. All right, you got that? So all this is right here is this, all right? And all we did was we replaced it with this CL right up here. All right, so now the CL is gone, which is what we want. That's good. Now the last step is to just combine everything, all right, to simplify it. So basically, whenever you have two terms that are the same on the top, you just put a little 2 at the top. So this is going to become K of NO2CL. And there's a little 2 right there, right? Because you're just multiplying these two together and they're the same term. All right, so you just put a little 2 right there, divided by NO2. All right, and if you ever have terms that can cancel out, like if there was an NO2 here on the bottom and there was an NO2 here on the top, you could just cancel those out. And the K's always cancel out, so you're always just going to have 1K. All right. Hopefully that makes sense. One more thing to point out real quick is, unlike when we did the rates for the you remember last time we did the rates, when we looked at an equation, the coefficients didn't matter, right? So like if there was a 2 here and we were trying to find the rate, we wouldn't worry about this 2, right? Remember us talking about that, hopefully. This time, however, for some special fun reason, they decided to decide, well, now that coefficient actually does matter. All right, so anytime you're solving one of these and you see a coefficient, that coefficient is now going to mean something. And all that it means is just that's going to be the order of that reactant. All right, so I'm actually going to put this to, actually, no, I'm going to keep it there, yeah. So, for example, ordinarily, when we see this one like before, we would get the rate to be K times NO2CL, CL, right? We wouldn't worry about this 2 right here. We talked about that last time. But this time, since there's a 2 here, we got to put a 2 right there, too. All right. Now, it's tricky because this is only for what we're doing right now, which is rate laws. I don't know the exact one, but what we're learning right now, what we learned today, right? This is only for solving rates with equilibrium, basically. Remember when we did rates before, I told you that the coefficient doesn't matter, and that's true, it doesn't. However, for some reason, they decided to change it, and for these equations right here, anytime you do have a coefficient, you're just going to put the same number right by the reactant. All right, so 2 NO2CL becomes NO2CL with a 2. If there was a 2 before this chlorine right here, it would be the same thing. You would just put a 2 right there. So hopefully this helps. I know, sorry, it was kind of jarbled a little bit, but hopefully this helps. Yeah.